welcome everyone to the past, present and future of cloud native API gateways. Now I appreciate a couple of buzzwords in there, 11R cloud native, right? But let's break it down a little bit in terms of a high level takeaway. Make sure I get my mouse working. So my pitch today, my kind of high level key takeaways is that the edge and API gateways have undergone a series of evolutions over the past 20, 25 years. Most of these evolutions have been driven by architecture and technology. If we move this cloud native way of working, microservices, Kubernetes, DevOps, all that good stuff, this is a fundamental change, I think, in the workflow as well. And this is knocking on not only to the API gateway, to the platform too. The way you choose your Kubernetes or cloud native API gateway, you should do it intentionally. I see a bunch of folks I work with as a consultant and now with Ambassador Labs who kind of either lift and shift the old world into the new or kind of fall into creating a platform. Just use what's sort of out there, what they've already got. And my advice to you is to be very intentional about the platform you are deploying and releasing software onto. That's the meta message today. This is me at Daniel Bryant UK on most of the interwebs. I do work at Ambassador Labs, so shameless plug, we do have the Ambassador API Gateway, open source gateway. We're just donating it, or in the process of trying to donate it to the CNCF now. So hopefully you'll see more about Ambassador in the Cloud Native Computing Foundation. My background is very much Java development, then went into architecture and ops, and now I do more product stuff with Ambassador Labs. I write on InfoQ, so you can check me out on InfoQ. And a buddy of mine, Abraham Perez, and I wrote a book on continuous delivery in Java a couple of years ago. Big fan of continuous delivery. I've changed my world when I bumped into it sort of many years ago now, I guess. The edge is slightly an overloaded term. When I chat to some folks in the IoT space, like edge for them is edge devices. If I chat to the CDN folks, edge is points of presence. And in my world, edge is the boundary at my data center. If you're in sort of Kubernetes world, edge is kind of ingress in my world. So when you hear me talk about the edge, that's the edge I'm talking about. The edge of the data center, your ingress, your networking, your edge stack, I often say. It's maybe a CDN, you've got WAF, you've got layer 4 load balancer, layer 7 load balancer, API gateway, all these things. When I say edge in this talk, that's what I'm referring to. Now, the thesis that we kind of come up with in Ambassador Labs is the evolution of the edge has primarily been driven by application architecture and tech over like 25 years or so. And let me run through very quickly, first sort of 10 minutes of the talk, I'll run through the history, then I'll look at some of the challenges with microservices, and the final 10 minutes, I'll look at some of the challenges and strategies around Kubernetes platforms and API gateways. So showing my age, I was still in high school in '95. I was getting into tech, but I wasn't actually commercially working, but Java was all the rage, right? Loving the Java. Back in like mid-90s, the web wasn't fully formed in some ways, so folks weren't sure whether the browser was going to be the way you consume content, or maybe something like, dare I say it, applets in the Java world was going to be the way we consume content. So there's lots of debate, but you start to see the client side, the back end, and the database kind of model. From an edge perspective, it was all about hardware load balancers. Sysadmins were the target users. The focus was on high availability and scalability. If we have more folks coming in, we route them to different backends. If one backend falls over, we just remove it from the pool and keep routing traffic to other places. In the 2000s, this is where I was in university, college. I was doing sort of a bit of consulting on the side. Still the same architecture. Seeing a lot of .NET, ASP.NET, a lot of Java stuff, front-end, back-end, database. But we saw the rise of software-driven edge technologies. Hat tip, HA Proxy and Nginx, can you believe it? They've been with us pretty much 20 years, still going strong. They changed the game by moving from hardware to software. No longer did you need dedicated, expensive hardware. You could run some of this stuff on what we would now call commodity type hardware. The target users were still sysadmins. This was kind of pre-DevOps, still the same goals as with the hardware load balancers: availability, scalability, health. 2005, this is when my career really started kicking off. I'd left university, sort of working my first proper gigs for the UK government and other places. We were doing a lot of what's now, slightly funnily, called Web 2.0. This was a big deal back in 2005, right? I was doing a lot of work in e-commerce. Ajax was a thing, again, showing my age, and anyone on the call is nodding along going, oh, Ajax, yeah. They're probably the similar age to me. Like Ajax was a big thing. What it allowed is the dynamic updating of the DOM, of the web pages. Previously, it was all request, big response. Another request, big response. Whole HTML pages coming back at one time. I remember doing a lot of JSPs, ASPs back in the day for how we delivered content. Ajax meant we could make these asynchronous calls and update bits of the DOM dynamically. This changed the calls to the back-end systems, and it gave rise to something called an application delivery controller. And the goal of this is, as we're making more requests now with smaller requests, smaller payloads, there was more things going on the back end, there was more connections being made. We wanted to offload some of the cross-cutting concerns into a new edge component. The ADC was still targeting at sysadmins, and I'll be honest, ADC is somewhat of a marketing term. You'll recognize some of the functionality, but it's definitely a thing. Like the vendors talked a lot about ADCs. It was all about high availability and application acceleration. Back when these were things, web servers doing SSL, TLS was actually quite intensive in terms of CPU. That's obviously changed now, but we were looking to offload some of these cross-cutting concerns into another component in the stack. ADCs were doing SSL offload, caching, compression, and a bit of load balancing too as well. F5 leading the way in this, in the hardware side, Nginx leading the way in the software side. The kind of funny thing now is, of course, F5 own Nginx, so the world has come full circle there, but these were the big names in that particular time. 2010, the I generation. I was doing a lot of work with APIs at this time. There was a big talk about API economy. All us developers could get rich because we'd build APIs, we'd mash them up with other folks, and we'd charge lots of money. The reality was that didn't quite happen, but I was still doing a lot of work with Google APIs, Google Maps APIs, and Stripe in particular. This led to the first generation of API gateways. Mashape spawned Kong. Like Mashape were going to be a marketplace for APIs. They realized Kong was how do they make money better? So they spun up Kong, and Kong obviously is still going strong now as an API gateway based on top of OpenResty, Nginx effectively. This was when we first saw the target users being sysadmins and API developers. When I was doing more dev work, this was a big deal. I was now thinking about the edge rather than just my back-end systems. I was thinking about how I can mash up these APIs, how I can monetize them. And because we were doing a lot of these kind of application-level APIs, HTTP REST-like APIs, the features in the gateway started looking at layer 7 in the OSI stack. Before it was all layer 4, now layer 7, you're thinking more about HTTP. Rather than say do routing decisions based on IP addresses or ports at layer 3, layer 4, now you're making routing decisions based on HTTP metadata, header data, the user agent, for example, direct, iPads over here and web browsers over here. Big shift towards layer 7. 2015, this was the kind of fail whale generation, right? If you remember this back in the day, Twitter constantly falling over. Ruby on Rails monolith. I was doing a lot of work on Ruby on Rails at this time. Fantastic for prototyping, fantastic for looking for product market fit, but Ruby on Rails doesn't always scale so well, is the reality of the situation. This is when, famously, what we're now calling microservices, but kind of mini services popped up. We saw James Lewis talking about Java the Unix way. We saw Fred George talking about mini services. We saw Martin Fowler, Sam Newman coining these things as well. The first generation of these things was still using the monolith typically to do a lot of cross-cutting concerns. The monolith was making routing decisions. The monolith was often doing auth. I actually worked on a project at Not on the High Street, a UK sort of two-sided marketplace, and we were doing exactly this. We were using the Ruby monolith to make routing decisions, Ruby monolith to do auth, and when we spun up these new business, bounded context, new mini services, we'd have to alter the monolith to get it routing to our service too. So that it was a bit awkward. And when you do a change in a service, you wanted to release that service, but you were coupled to the release train in the monolith quite often. Second generation of API gateways spun up to counter this. Cross-cutting concerns like the routing was pulled out of the monolith into an API gateway. Authentication was pulled out of the monolith into the API gateway. Rate limiting, all these kind of things were being pulled out of your application code into an edge component. Often they were combined with ADCs, web application firewalls, CDNs, these kind of things too. The edge stack was becoming more of a thing. We had different components in the stack being responsible for different things. And this is kind of like separation of concerns, single responsibility, all good things we know and love from any kind of software development. And it's becoming a thing around this time frame. The target users were still sysadmins and API developers and app developers. centralizing cross-cutting concerns was the main goal with second-gen API gateways. And again, we're doing a lot, even we as developers now have to think about auth. Maybe a marketing sign-up service is different auth requirements than a back-end payment service, for example. We're also thinking about things like more network level concerns, circuit breaking, timeouts, retries, all that good stuff too. So that's a bit of a tour de force of the history of where we're at. Now let's look, the cloud has become a big thing over the past 10 or so years, right? We're talking a lot about microservices. Now, of course, this isn't new. David Parnas talked about this in the 1970s, modularization. I'm sure many folks were doing that before even the 1970s. But we're now talking about microservices, bounded contexts, hard network boundaries, modularization at its core. You can build, you can release, and you can operate each business function, each service, independently, and you can scale them independently too. If you look on the back end, we are spoilt for choice. Back when I was kind of doing my thing, like it was pretty much VMs, on-prem or colo. Like you chose that. Now we've got Kubernetes, we've got on-premise VMs, cloud VMs, PaaS, FaaS, you name it, we've got it. We are spoilt for choice in some ways. Fantastic. It's an opportunity, but it's also a dilemma sometimes. And our tech, our edge tech in particular, has to integrate with all these different backends. And the different backends have different properties. A lot of different protocols now. We're seeing a lot of gRPC in Ambassador Labs, gRPC Web too. Folks are prioritizing that over normal REST-like services we're starting to see in some of our use cases. We see different load balancing requirements. There's a lot of older style, vintage, money-making apps, right, that need sticky sessions to work. You've got to hit the same backend all the time. We're seeing the more modern services like function as a service, spin up and be completely ephemeral. Spin up for a few minutes, disappear. And we see a lot of our work is around authentication. We want to get this right. Security is really important. Cybercrime is on the up. Cybercrime is on the up. Just in general, you don't want to be subject to kind of folks hacking your systems or spoofing your users. So getting the auth correct is really, really important. If we had to summarize now, our kind of API gateway, our cloud API gateway, you have to do a bunch of things there now. You need the API gateway type management capabilities, authentication, dev portal, sharing your open API specs, all this kind of stuff, maybe generating mocks and stubs, things kind of things. And you want some way of getting observability into stuff as well. You do need this ADC-like traffic management capability. Netflix have talked a lot about sort of internal comms around timeouts, retries, circuit breaking, bulkheads. You need the same kind of thing at the edge too. And the back end now is dynamic. We've got some Kubernetes in the mix. We've got some VMs in the mix. We've got some functions in the mix. This is proving quite a challenge at the edge. The key thing though is microservices done correctly, not just literally monolithic principles, smaller service. Microservices done correctly lead to an even bigger change. I really like this. It's a cliche now, but Werner Vogels is a super smart person, CTO of Amazon. Several years ago, he was saying, you build it, you run it. And this is what I'm seeing in my work these days. More and more developers I chat to are responsible for the full cycle, the full life cycle of a service. Doesn't mean platform isn't a thing, doesn't mean ops aren't a thing, but it's a different relationship now what we're often working with. Developers, we have business ideas, we code, we test, we release, we get the feedback, and we iterate. We're consuming a lot of these platform services via APIs now, via SDKs. The challenge is, as a developer, it can feel a bit like this, right? So, the one-person band, full stack. When I was I was in my career, as a developer, was I knew JavaScript and Java and a bit of SQL. That was all good. Now I've got to know Terraform, Node, Java, Ruby, Go, Kubernetes YAML, Helm. There's a lot of stuff going on, right? I definitely feel overwhelmed. I'm sure you do at times too. But I still like the idea. The idea you're coming up with. When you code it, you own that from idea to production. It actually makes sense, but back in the 2000s when I started coding, it wasn't this. I coded some stuff up based on a fat telephone directory of requirements. I handed off my jar file to ops, and I maybe got some feedback when the users weren't happy. Kind of nuts when you think about it, but this is how it was. These days, our competitors are going to be going faster or trying to go faster than us. We need to make sure we've got the ability to go quick. I really like this concept of full cycle development. So Netflix are pioneers here, and I know we're not all Netflix. In fact, only Netflix is Netflix, right? But I like looking at these kind of companies for ideas. And they talk a lot about how they have platform teams that offer things like build tools, pipelines, consulting services. SRE, site reliability engineering, is kind of in this wheelhouse too. But the primary goal of all these very smart folks working in these teams is to, oh, I've messed up my animation, sorry, is to support the developers, the full cycle developers. The platform teams offer services and APIs, and the developers, we just consume it. We have the idea, we design, we want to deploy, we ideally sort of have our deployment descriptor pushing down the same pipeline as our application code, and the way we release functionality, the way we sort of change the configuration is all using the same mechanisms. And what I meant to do was animate here team topologies. Fantastic book. I've actually shared it at the beginning. I've got a copy here. I literally keep it on my desk. It's such a good book. I'm lucky enough to know Matthew and Manuel from the London tech scene and from the Portugal tech scene and Lisbon. I've learned a lot from Matthew and Manuel. They have codified some of the ideas around full cycle development, particularly in terms of platform teams and how you interact, into this book. And it's a fantastic read. I can't say enough about it. It's a really good book. But it really helps me think about this notion of product teams, stream aligned teams, working with platform teams to deliver value. Say again, it's a change in workflow. Back when I was doing my thing, it was like, requirements, code, handoff. Now it's different. I've got to bake in metrics. I've got to understand, am I affecting my KPIs, my key performance indicators? Am I delivering value to my end users? Am I burning CPU too much? Am I, we have SLIs, service level indicators. Is my recent change affecting conversion because I've messed up the latency on a request call? That kind of thing. Like, now we need full ownership. It's a change in workflow. We are responsible end to end. I think this is really going to impact. When I say I'm standing on the shoulders of giants, both in the community and in my team. We think the future evolution of the edge is going to be driven by architecture, for sure, technology, no doubt, but also workflow. Architecture, we've kind of got all the choices now. We've got nano services, functions, we've got the monolith, we've got everything in between, right? But the way we work with these systems is really going to be the differentiator, I think. So now I'm going to go, it's going to be high level still, but I'm going to dive into some problems with Kubernetes. And I've chosen Kubernetes, I think it's, it's the main thing now, right? Sure, you can use cloud vendor specific PaaSes and things like that. But a lot of these lessons, hopefully I'm going to share now, a lot of these learnings, mistakes I've made are sort of shareable in that context even too. The biggest thing in this kind of move to microservices cloud native is scaling edge management. Back when I was doing my dev work, we often controlled the whole stack, including cross-cutting concerns. If I wanted to tweak the auth, I tweaked the library. If I wanted to tweak the rate limiting, I tweaked the library, did a build and deploy. If I wanted to tweak the caching, so many times I've lost time to caching. Caching and DNS, right? Bane of my life. And DNS is out of my control, but caching I could tweak typically in a library and deploy. If I needed to change the edge, the platform team typically owned that, the ops team owned that, I'd raise a ticket, there'd be some backwards and forwards, and I have to bake this into my SLA. If I was going to be delivering functionality within 2 days and the ops team's turnaround was guaranteed to be 2 days, well, we need to have that conversation first. Hey, I'm opening up new ports. Hey, are you going to support WebSockets for me? Hey, I need HTTP 2. We need to get those conversations kicked off early. This is a big challenge in the kind of full cycle world where I need to be moving really fast. We're pulling up the cross-functional requirements from our apps now. Maybe you've got some Java, some Go, some Ruby in the stack. You do not want to be having language-specific libraries doing the things now. I worked on a couple of projects where we had a Ruby version of service discovery, a Java version of service discovery, a Go version of service discovery, all with subtle differences in terms of timeouts and all these kind of things. It's like, nightmare. It makes sense to pull it up, but you imagine now we've got more and more services being spun up. And that's the beauty of microservices. You write them to be replaceable. You can write them to be ephemeral, but I need some way of interacting with the edge now to say, hey, I want auth to be like this. I want retries to be like this. I want caching to be like this. Scaling this management of the edge does not work with tickets. I've seen a few companies try and do it. It's really hard to do. I've hinted a couple times, no longer are we just, classic REST-like JSON over HTTP. A lot of folks are bringing in gRPC. A lot of folks, have got WebSockets as well. And I've seen some problems where folks have got old gateways, maybe they've built them themselves and they only support HTTP 1.1. And to do gRPC properly, you need HTTP 2 support, these kind of things. And you kind of don't want to be, like, if you suddenly go, hey, we're deploying a gRPC service, and your ops team says, oh, this gateway doesn't support it, that can be like a massive blocker. So we need to look at this kind of flexibility to be able to mash up the different protocols and again, customize what we want in terms of cross-cutting concerns. And cross-cutting concerns mean different things in different worlds, like caching in gRPC is different than caching in REST and these kind of things. So you need the expertise and the ability to mash up these things effectively. 3 broad strategies, and again, these are high-level strategies. We can go into some perhaps the deeper dive in the Q&A, and I can point you at my team who know even more about, say, Envoy and Nginx and stuff than I do. But the 3 strategies I've seen folks use when sort of moving to Kubernetes, moving to the cloud, are these. Often folks deploy an additional Kubernetes API gateway. They spin up a Kubernetes POC next to their existing system, and they have everything brand new in this cluster, including a new gateway. If folks have built their own API gateway or are heavily invested in hardware gateways, they may extend their existing API gateway. If you're going greenfield, you're probably going to deploy what we're calling like an in-cluster edge stack. That basically means all the things at the edge, with the exception of CDNs probably, but things like load balancer, API gateway, developer portal, web application firewall, all these things now are going to be deployed into the Kubernetes cluster, or at least managed very strongly via the Kubernetes cluster. So if you're changing configuration in the WAF, you can do it via a YAML file, via a Helm values file, rather than having to go out of bounds and configure via an SDK or an API the changes you want. So it's all in the Kubernetes world. We've written some blog posts on this. We've got some white papers. You want to go into more detail, I'll sort of skirt through each of the options now. The first strategy is deploying this additional Kubernetes API gateway. It's pretty simple. Most commonly I see it like people literally spin up a cluster and put it underneath their existing API gateway, and they're passing through traffic, simply passing through traffic in their existing gateway to this new world. I do see some folks trying to do it at the layer 4 level, so they're based on IP addresses, domain names, ports, these kind of things, but same deal. They're passing through traffic. The existing traffic goes to the old world, the new traffic goes to the new world. There's a bit of a debate sometimes on who's owning what, and that actually causes a bit of confusion, which I'll talk about in just a second. But this is the fundamental approach a lot of folks take when they're just doing a POC with Kubernetes. They're just trying to figure out, is this for us? How do we work with it? The pros is there's minimal change to the core edge infrastructure. You've still got that happy path into your old money-making world. Yeah, the incremental migration is easy. As we get more happy with the new world in Kubernetes, we can lift and shift apps, or maybe not lift and shift. Sorry, my bad. Migrate apps. You don't want to really lift and shift. You want to look at each app, check it's good for the Kubernetes world, and then move it across. From a cons perspective, they're pretty obvious too, right? It's increased management overhead. You've got 2 gateways in the mix. One really gnarly problem we had with a customer a while back was we were having some challenges around auth and security in the new world, in the new Kubernetes API gateway. And what it actually turned out was the original API gateway, the gateway sitting at the top, was stripping out some critical headers for us making decisions in the new gateway. But trying to figure out where in the stack these things were happening, and it wasn't documented and stuff, was just a nightmare of debugging. And who was taking ownership? Was it the old gateway team? Was it the new gateway team? These things were really quite gnarly. You know, all workable, but we should have probably got together a bit earlier with the old team and told some of our requirements, or discussed, sorry, some of our requirements, and understood how we were going to work together better. We also had a bunch of problems where folks in the new world wanted to do things, but they had to chat to the old world and raise tickets typically to get changes done in the old gateway. Because that was the first point of contact, we had to change that gateway before we could do our stuff in the new world. But this is a totally viable pattern for migration. Like all these strategies I'm talking about, one is not necessarily better than the other. They all have trade-offs. And this is a nice pattern for getting started if you're moving to the cloud. The second pattern is extending your existing API gateway. This is typically implemented by modifying or augmenting your existing API gateway to sync up your endpoints with their location. So I've seen like a lot of, you can do this if you've written your own gateway. I've seen a lot of vendors like F5 and Citrix offering this kind of thing too, where they deploy an operator or a controller, something like that, into your Kubernetes cluster. It watches for annotations on your Kubernetes YAML, and then based on those annotations makes calls out of bounds, out of band, to the API gateway. So it gives me some annotations on my Kubernetes YAML. I do a service. I say expose this service on this endpoint or with these configs in my auth or whatever. And the controller sitting in the cluster goes, oh, new annotation deployed. And it basically joins the old world with the new. It looks into my annotations, converts it into the SDK API calls, into the hardware gateway, for example, and makes those changes. I've seen a bunch of folks that have invested in their own gateway do the same kind of thing. They'll often sort of build a plugin or some kind of module that syncs up the old world and new. Pros, again, you're reusing the tried and trusted gateway. This is kind of a good feeling rather than doing a big bang. If you're trying to do like sort of lift and shift or completely change the way you do edge traffic, it's always high risk. So this is a nice way of sort of tried and trusted gateway. You can leverage all your existing on-prem stuff if you've invested heavily in F5 or Citrix or something. You can still use that kind of technology. The cons are that the workflows must change to preserve a single source of truth. We had a couple of gnarly issues where folks were doing this kind of thing, and they were making changes in the new world that were conflicting in changes in the old world. Or we had like race conditions where people were like tweaking things, and like we were tweaking them in the new world. The controller was looking at the annotations, it was making calls onto the gateway, and then someone was loading a manual config in like via a config file that was conflicting with our changes. So it was, oh, we need to like actually have some kind of pipeline, like almost like a, or some kind of a collaboration tool to ensure that we're not stomping over each other's work when we change things. And I did find there's a limited amount of config parameters in the Kubernetes annotations. Sometimes you want to tweak some caching, and you're looking for the annotation in the Kubernetes world. Like, how do I know I can change the caching in the gateway? How do I do it in the Kubernetes world? And that's not supported. Because, hat tip to all the fantastic teams out there working. There's only so much they can do, and they typically support the annotations with the most popular functionality first. So yeah, if you want to tweak some stuff in the Kubernetes world, you just can't do it. You have to, again, go out of bound, raise the query with the platform team, raise a ticket, and change the actual config. The final pattern is deploying an in-cluster edge stack. And this is where you put as much as possible in the Kubernetes cluster. And the beauty of this is you control it all via the same pipelines. If you're into GitOps, all that kind of good stuff, WeWork's got the Flux product, similar kind of deal. Like whether you're deploying code, config changes, releasing versus deploying, all these kind of things, you're doing it via the same mechanism. If you're in the Kubernetes world, you're using CRDs, typically custom resources, and how you deploy a service uses the same pipeline as how you release the service. Maybe you're doing some canary testing, or maybe you want to tweak the auth. It's all using the same pipeline as a single source of truth here. Oh yeah, that's animation there. The pros is that edge management is simplified into a single stack. There is a single source of truth. And again, if you haven't bumped into GitOps, well worth a read. I haven't got time to go into too much of it here, and other folks know way more about it than I do. I do often point at the Weave team, WeaveWorks. These are good practices though. Single source of truth, declarative config, we define our state of the world, some controller in the middle reconciles our desired state with the actual state in the cluster, in prod. These are good things to do. You minimize the clashes between old and new. Cons is potentially a large architectural shift, and a large responsibility shift. We as developers are now more responsible for edge things. Platform teams have also got to learn more stuff. A lot of technology, a lot of edge technologies like Contour, Ambassador, Glue, they're built on Envoy. And that does require a bit of a shift in terms of how the actual technologies work. So if someone's been running Nginx or F5 all their life, they'll need to learn new things for how Envoy behaves, for example. Got to factor that into any kind of work here. So wrapping up, hopefully this has been a bit of a tour de force, a bit of a high level kind of a tour to get you thinking. Edge and API gateways have undergone a series of evolutions. I think mainly driven by architecture and tech. There's definitely been a move from hardware to software. It's cheaper, it's more malleable. Layer 4 to layer 7, we care more about the granular stuff now. Are you on an iPad? Where's your auth setting, auth header setting? These kind of things. We want to make routing decisions based on layer 7 HTTP metadata. We're moving from a centralized management to decentralized. Ops teams have centralized guardrails and guidelines, but dev teams are kind of responsible for the day-to-day configuration. If you're adopting all this good cloud native approach, there's a change in workflow. If you're doing it right, there should be a change in workflow, in my opinion. You do need to think about scaling the edge management. You do need to think about the self-service model of supporting multiple protocols and cross-functional requirements, making it easy for developers to do the right thing. think that's really important. Make it easy for developers to do the right thing. And the meta message here, now I've talked a lot about cloud API gateways, but the meta message is really do design your platform intentionally. If you're releasing web-based software and many other forms of software, you have a platform, whether you realize it or not. Kubernetes is a fantastic foundation of the platform, but you often have to layer other things on top for it to be a fully functional platform-like experience, a PaaS-like experience. And I've done this mistake in the past where I've just kind of fallen into building a platform accidentally. I would argue that you should think about your requirements, map it to the technology out there, map it to your skills, look at the strategies I've talked about there, which one favors your requirements best, and then increment and iterate based on the feedback you're getting. Having a playground is really useful. So I did an article on the Newstat a couple of weeks ago talking about the need to spin up a playground for testing around these things. We've got a free tool on app.getambassador.io, which allows you to answer a bunch of questions about where your Kubernetes cluster is, and it spits out some fully formed YAML that configures all the things I think are essential for a platform, like edge, observability, and continuous delivery. We've got Argo, which is great CD tool in there as well. So we're trying to make it easy for folks to experiment with these things. No sales pitch there, it's free tool, no reg required, but we think this is a good way of getting started to poke and prod around Kubernetes and Edge and how it relates to your apps too. Lastly, you can find a bunch more stuff on the Get Ambassador website. You can find my musings on InfoQ, do some podcasts for InfoQ, podcasts for Ambassador too. Find me in the DataWire Slack and on Twitter, and I'll be hanging out in the GOTO Slack for half an hour or so now as well. And happy to take some questions. Thanks a lot.